Hi, welcome to another video on Gre Quant. In this video, we will solve a coordinate geometry question on quantitative comparison type that you see often in the GRE test. Quantitative comparison questions occupy typically 30 to 40% of the total questions in the quant section of the GRE test. Okay, and I assume that you are familiar with a quantitative comparison type of question in the GRE test. I assume means below the question you will find four answer options A, B, C, D. Option A will be clicked as the right answer if you find the terms under quantity A as greater than those in the quantity B, or you will click option B for answer if quantity B is greater, C for answer if the two quantities are equal, and D when the given data in the question will not be sufficient to compare the terms given under the two quantities. Now coming to the question. I have drawn an inverted parabola on the board with a point below the curve graph of the parabola. The coordinates of the point are S and T. In quantity A, there is T, which is the y coordinate in the point, and under quantity B, you have 2s minus s square. So compare T, the y coordinate in quantity A, with 2s minus s square under quantity B. Which do you feel of the two quantities is the greater one? Okay. Also, we are given as part of essential information the graph, the equation of the parabola, which is y is equal to 2x minus x square. So with this amount of data being given to us, we are supposed to compare t with 2s minus s square. Now let us proceed with the solution. Imagine a vertical line drawn like this, perpendicular to the x-axis. As you know, this is the x-axis. Now, this vertical line passing through the point S comma T will touch the x-axis. At what point? My question is, the point on x-axis at which this line will touch the x-axis, that point will have what coordinates? I think you guessed it. It will be S0. As you know, all y coordinates will be 0 for points that lie on the x-axis. Here the point of intersection of the straight line with the x-axis will be touching the x-axis at this point. So certainly the y coordinate of this point which lies on x-axis has to be 0. Nothing other than 0 for a point lying on x-axis. The y coordinate has to be 0. And why should the x coordinate of this same point be s? Because this line is passing through the point S comma T, and for all points lying on this line passing through the coordinate S0, the x coordinates will be always the same s. Y coordinates will be changing or increasing as the line is observed to be moving up, while the x coordinate will be the same s. for all points lying on this line passing through the point S0 on x-axis. Okay. Now, so at the point of intersection of this straight line and the parabola here, also the x-coordinate has to be S. As I said earlier, for all points lying on this straight line passing through the point S, 0 on x-axis, the x-coordinates will be S, with the y-coordinates of course changing, therefore different. But the x-coordinate will be the same S for all points lying on this straight line passing through the point S0 on x-axis. So since this point lies on the line and the parabola, since this point lies on the line also, therefore its x-coordinate first of all has to be S. Next, since the point lies on the parabola also, so you can obtain the y-coordinate of this point by doing what? By substituting the x-coordinate S in the equation of the parabola. Why so? This is something that you must be familiar with. If a point lies on the curve of the parabola, then x-coordinate and y-coordinates of that point can be substituted in the respective places of x and y in the equation of the parabola, because the coordinates of the point will satisfy the equation of the parabola. Therefore, I am authorized to substitute S in x here. So what will be the y value that you will get after substituting S in x? It will be 2s minus s square. So that means if the coordinate of x is s in this point, the corresponding y coordinate of this same point obtained by substituting s in x in the equation of the parabola will be this expression, which is 2s minus s square. 2s minus s square will therefore be the y coordinate of this point that lies on the parabola, with the x coordinate being s. Let me rewrite it: 2s minus s square. Now we have obtained this expression under quantity b, 2s minus s square, as the y coordinate of the point whose x coordinate is s. Okay. Now, so 2s minus s square has to be compared with t. 2s minus s square is the y coordinate of this point, while t is the y coordinate of this point. As you can see from the figure given on the board, 2s minus s square is the y coordinate of a point that lies above the point in which the y coordinate happens to be t. Now, if you recall, for all points in the xy coordinate plane, for all points lying above, the y coordinates will obviously be greater in value than those of the point, than the y coordinates of the points that lie below them. Since the point s, t is given in the figure to lie below the point on the parabola in which the y coordinate is 2s minus s square, therefore this y coordinate t has to be less than 2s minus s square. So what do we have finally? quantity A, y coordinate t is less than quantity B having the y coordinate 2s minus s square. Therefore, for this question, our right answer will be quantity B, meaning expression under quantity A is mathematically less than the expression under quantity B. I hope you followed this video and made some benefit. Thank you.